Hello everyone, so welcome to a new video. So in this video we'll see how we can configure and connect Sinamics G120 drive, Siemens G120 drive with ABB AC800M PLC, and we'll see how we can control it. So this is a PLC I got PM866. So I have a CA854, that is a Profibus master, and this Profibus cable is connected to my Sinamics drive. This is my G120 series drive. So I have a CU240p 2DP control card. So this is the card I'm using to communicate with the PLC. Okay, so we'll see the so I'm using Simmersion Scout to connect to the drive. So we'll see the basic setting what we require. So if you go to configuration, IO configuration, so I have already set the Profibus address, which is 6. Okay, and then the I'll use the free telegram to communicate with the PLC. Okay, so in the receive section you don't need to configure anything here. It is already configured as a control word. So this is the control word for giving commands to the drive, and the second is the set point, which is the when you are running the speed the drive in speed control. I'll be sending the speed reference to this particular parameter. Okay, so in the transmit direction, that is from the drive to PLC, I have connected this to the status word from the drive, and this to the actual speed. I will take one more, that is the DC bus. So we'll take the DC bus voltage also, like I'll take this one. Okay, so this is the data that are sent from drive to PLC. So this part is done. Am I online? Okay, I'm online. Oh sorry, I was not online the drive. Yeah, so this is my Profibus address. So wait, I have to do that again. So this I have selected free telegram, and I have to connect DC bus. Okay, it's done. Now I will go to the PLC side. So in the PLC side, we'll create a new program, that is for Siemens G120. So we'll add the hardware. So I have a PM866. Let's set the IP address. So my IP address is 192.168. This is my IP address. I'll set okay. I have to set this also. The control system identity. So I have to add the hardware. First I have to add this one, CA854, which is the Profibus master. So let's add that C854. So that is done. Now I have to add my Sinamics drive. So first you need to install the library, I mean the GST. So let's create a new library which is called Sinamics G120. Okay, so now we install the GST file. So for this you need to download the GST file from Siemens website. So I already did that. So it looks something like this. So you need to select GST. Okay, click next and select the one that you are going to use. So I'm going to use free telegram because that is what I configured in the drive. As you can see, I'm using free telegram. Okay, so I'll select the same. So click next. So here you need to define how, in which format you are going to receive it. So I'll use double integer signed. Okay, now apply. So this will create channels. So it created 16 channels, which means I have 8 inputs and 8 outputs. So that's it, we are done. Now I need to connect this here so that I can add it here. So Sinamics G120, the Profibus address is 6. Okay, so the basic hardware is done. Now let's start making the program. So to do that, let's go to the application. You can delete whatever is not required. I'll rename it as Siemens program. Okay, so we'll write the program in FBD. Okay, so before doing that, we'll have to read the manual, the Profibus manual for the Siemens to understand what is how the status word and control word is. So I'll open that. So let's read the manual. So this is the status word. Status word is a 16-bit data that is sent from Siemens drive to the PLC. So as you can see, my transmit direction, this is the status word. Okay, so this is what it is sending. This is the 16-bit data that is sent. Okay, so let's in the program, first we will define status word. I'll call it as SW, and before doing that I need to do one more thing. Okay, so we created the hardware. Now let's add the PZD. So I created this free telegram, so we add that here. Okay, so the first input will be the status word, second input will be the speed feedback, and third will be the DC bus voltage. So whatever you want you can add on here. So I added 3. I will add 3. Okay, similarly the first output will be the control word, second will be the speed reference. Okay, now let's create the program. So status word, and you need to know that I defined this as a double integer, so we need to do the same here. Now speed feedback, then speed reference, then the control word. We'll call it as CW. Okay, it's all double integer. Okay, now we need to decode this status word. Okay, so as I said, It's a 16-bit. So let's create the function block let's use the block directly. I'll use dint to bc. Okay, so you can define the size. I'm going to use it as a 16-bit. I want to convert this double integer to a 16-bit bool. Okay, so SW, which is the status word. Now the first bit. So to understand this, you need to read the manual. So the first bit is ready to start, second is ready, operation enabled. So all this meaning of each bit. So I just created all this here. So these are the 16-bit as per the manual. I just made the variables here. So we'll copy paste that. Okay, so it's all bool data type. It's a bit. Okay, so the 16-bit is done. So now what we can do is we can copy all this. So and we can put it here. That's it. So the status word is done. So we converted this status word, which is 16-bit, and converted it to 16 bits. Okay, so that part is done. Now the speed feedback. So we are receiving speed feedback in percentage. So we have to divide it. This is the speed feedback. It's a double integer, so we have to change this to double integer. So divide by 200, which will give you the speed feedback in percentage. Okay, similarly, now let's focus on the control word. So the control word is again a 16-bit data. So I'll use another block for this, bc2 double integer. Okay, so I'll connect the control word here. Now how to start the drive. So the control word is the data that we are sending from PLC to drive. So again, it's a 16-bit, so each bit has its own meaning. So we'll use this first bit to start the drive, and this bit is like self-explanatory. Like if you are using the off to control, you need to connect that. If you are not using, keep it as 1. And quick stop, if you are not using, keep it as 1. You need to enable operation, so this bit should be 1, this bit should be 1. This we are using a ramp, so this should be 1. Then set point we are using, so this bit should be 1. Then this is the reset bit, the 8th bit should be reset, and these two we are not using. And this bit should be 1 because we are going to control it by PLC. And this bit depends, like if you want to use it input to reverse direction, you can do that, but I will use the positive and negative speed to reverse the direction. So this bit is not used, and this all should be not used. So I'll do the same thing in the program. So So this is the start bit. Okay, there should be one. Okay, now the control word is ready. Now let's give the speed reference. So I have to multiply. Oh, what is? So I need only 2 and it's double integer. Okay. So speed reference in percentage. So multiply by 200, and this is the one that we are going to send to the drive. So this one. Okay, done. So we save it. Now let's connect all this. So as I said, the first should be the status word. Second should be the speed feedback. Okay, then we have a DC bus voltage. Oh, I have not created that. I'll create again. So control word, speed reference. I'll make the DC bus voltage also. DC double integer. Okay, so that is done. Now let's save it. We'll do a download. Okay, we are online with the PLC, but the drive, yeah, so there is no fault, it's just warning sign only, so this is fine. Now let's see what we are getting. Okay, so we are receiving something from the PLC, sorry, from the drive, and yeah, before doing this, there is something that you need to remember. Since I configured the status word as the double integer, I'm getting a negative sign over here. So, but the drive is sending this value 60209, but I am receiving a negative value here. So actually, since this is in hex, we need to remove this negative sign. Means if you see the calculator, the hex value, sorry, let us Yeah, so we need to remove this negative sign. So the we need to add this by 65536, which means hex value of this much. So what I will do is, because whatever you are getting is not correct, we'll insert additional block and I'll connect here. Double integer and 65536. Okay, so now you will start getting the correct value. Okay, so now we have the correct details from the drive. Now let's see, if I give a start command, you can see the drive started. You can see operation enabled, no fault active, and you can see that the same thing. Okay, so now we can give a speed reference. I'll give, let's say I'll run the drive in 10%. So you can see the drive is running and the speed feedback is coming. You can set to 50%. So drive accelerated to 50%. Now to reverse the direction, you can give a negative value. So it slows down and reverse the direction. Okay, so you can give any speed reference from 0 to 100, 0 to minus 100. So this is basically a simple program, like, so you can see here also it's the road which rotates clockwise. So this is how you make a simple program to control the Sinamics drives from AC800M PLC. So if I give a stop command, it will stop. Okay, so I hope this small program was clear to everyone. So thanks for watching the video again. So have a good day everyone. Thank you.